Section 5, RTUs. 5.1 General and Design Requirements. The RTU remote terminal unit shall be an advanced intelligent device designed for integrated control system applications, supporting enhanced communication capabilities and high-performance control strategies. Designed to monitor and control hydrocarbon liquid pipeline instruments and equipment at valve sites, metering stations, marketing terminals, pumping stations, CP, cathodic protection stations, and other pipeline facilities. The RTU shall interface with local instruments, field-mounted instruments, including transmitters, switches, selectors, indicators, and displays. 5.2 RTU features. Dual microprocessor-based modular electronic control device equipped with I/O terminals suitable for direct connection to field wiring of analog and digital control and monitoring devices. Supports multiple standard SCADA protocols, such as Modbus, multiple RS-232C and RS-485 serial ports, each capable of carrying a different communication protocol. Ethernet ports, minimum of 4 Ethernet ports compatible with IEEE 802.3 100 base T specifications. Communications management over redundant multiple links, including integration with DCS, RTU, electronic flow meters, and intelligent control subsystems. Local data archiving, processing, calculation, advanced control functions, and graphic display. Time synchronization via MCC with timestamping to 1 millisecond resolution for all digital, analog, and pulse accumulator inputs. Advanced control functions including PID, feed-forward, cascade, adaptive gain, ratio, override control, multivariable functions, selectors. IEC 61131-3 compliant with redundancy achievable at levels of CPU, power supply, and communication modules. Optional built-in graphic color display for local control and maintenance. Dual 32-bit CPUs with a minimum 166 MHz system clock and 32 MB SD-RAM, expandable up to 64 MB. Lightning protection and plug-connected terminations. 5.3 RTU performance. RTU scanning times for input and output points are specified in Appendix B. All analog and digital input points shall be time-stamped to the resolution indicated in Appendix B, with timestamps reported to the SCADA master station during polling. 5.4 Services included. Application and design engineering resulting in a fully integrated system. Complete system configuration, including RTU database, graphic displays, analog and logic programming, and interfaces to other control systems. 5.5 Communication features. 100 Mbps redundant Ethernet communication. Support for multiple communication protocols. Equipped with asynchronous and synchronous serial communication channels for VHF radio networks, telephone lines, ISDN, dedicated communication lines, satellite communications, cellular networks, and fiber optic links. 5.6 RTU configuration. RTUs shall be self-contained units capable of collecting data from dry contacts, current or voltage signals, and contact-making pulsing devices. Features include no false outputs during power up or power down, a minimum of 256 unique RTU addresses. Selection interlock to prevent more than one control selection at a time. Remote downloading of configuration parameter changes and application software. Remote diagnostic capability. Programming tools for minor software modifications and configuration via handheld devices or IBM-compatible personal computers. Capability to modify the program offline and online while the system is operational. 5.7 Enclosures. RTUs and associated hardware shall be mounted inside suitable enclosures accommodating full future expansion. Enclosures constructed from marine-grade aluminum, insect, weather, and vermin-proof, conforming to IEC 529-1 IP55 standards. Enclosures for outdoor installations shall have sunshades and document pockets for storage of documentation. 5.7.1 Construction of enclosures. Enclosures for remote sites shall be constructed to withstand environmental conditions, including high temperatures and dust. Features include insect, weather, and vermin-proof construction. Lockable with cam locks and fitted with sunshades. Internal temperature sensing device and loss of cooling airflow detector. Rounded edges and folds to avoid stress cracks and irregularities. 3-point latching doors with a minimum access way clearance of 2,000 millimeters. 5.8 Labeling. All enclosures and equipment within shall have identification as per the owner's philosophy. 5.9 Terminations and Input-Output Wiring. RTU configuration includes provisions for terminating all field multicore cables, including spares, terminating all system cables, including spares and interconnections, intrinsically safe and non-intrinsically safe digital and analog signals, #5.10 I/O connections, provision for easy removal and replacement of I/O modules without powering down the RTU. 5.10.1 Removal of I/O modules, designed to allow for removal and replacement without interrupting RTU operation. 5.11 Status input requirements. Isolated from high electrical noise, filtered for contact bounce, and configured to handle pulse counting accumulators. 5.12 Control output requirements. RTUs to process control selections and commands received from MCC, SMCC, and LCC. Outputs to motor control centers via interposing relays capable of switching 110 volt AC at 1/8 resistive. TAVR 5.113 Analog input requirements. Options for AD converter per point or input multiplexer. Minimum AD converter characteristics: 14 bits resolution plus sign. Input impedance greater than 1 megohm. Common mode voltage, 300 volts DC. Common mode noise rejection ratio, 80 dB or more. Differential mode noise rejection, 85 dB at 50 Hz. Accuracy, plies 0.1% over the full range of power supply. Linearization of standard thermocouple signals. 5.14 Insulation and isolation requirements. Insulation designed to withstand 1.5 kV RMS, conforming to IEC 255-5 test standards. Isolation resistance more than 5 megohms. High-frequency disturbance designed to pass a 5 kV impulse test voltage, conforming to IEC 255 standards. Section 6. Field Marshalling Cabinets. 6.1 General. The seller shall supply all necessary field marshalling cubicles, internal wiring, and equipment for the SCADA system. Cabinets shall provide the facility for terminating all field multicore cables, including spare cores, and interconnection and cross-wiring of these cables between incoming terminals or barriers. SARS 6.2 Construction. Marshalling cabinets shall be supplied with Alulux roller doors. The roller carrier impingement into immediately adjacent secondary safety access ways shall be minimized. The lower edge of this carrier shall be rounded off with a minimum accessway clearance height from floor level of 2,000 millimeters. All cabinets shall be supplied with 50 millimeter high channel section frame plinths for pre-shipment to module fabrication yards for welding into position. Shipping plinths shall be supplied for interim use during cabinet manufacture, testing, and transportation. 6.3 Panel Requirements. 6.3.1 Mechanical Construction. Panels shall be shipped with all components installed and fully wired. Panels are to be built by specialized panel manufacturers. The panel shall be installed within an air-conditioned building with a false computer-type floor, supported via a subframe bolted to the floor. The panel shall be constructed for installation at floor level and provided with a 100 mm by 50 mm plinth, continuous throughout the entire length of the panel. Press-formed methods shall be used for construction with internal reinforcement to prevent deformation and flexing. Each cabinet shall be a maximum of 2,100 mm high, including 100 mm channel base, 1,200 mm wide, and 800 mm deep. Construction shall be modular to accommodate 19-inch standard electrical racks. Panel finish shall be air-dried epoxy-type paint of semi-gloss texture, color Siemens Gray, RAL number 7-32, with internal color white. Hackshire 6.3.2 Identification. Each cabinet shall have an identifying nameplate fixed on the front and rear with screws. The owner's tagging system shall be used. Internally mounted equipment shall be clearly identified by nameplates using Trafalite-type WBW labels. Nameplates shall be engraved and secured with self-tapping screws. Hackshire 6.3.3 Wiring and Termination. All wiring shall be mechanically supported within plastic non-flammable trunking with covers. Power cabling and instrument signal cabling shall be separated to avoid interference. Wire use shall be 0.8 mm minimum. Field cables and system cables shall have separate trunking or trays. Wires shall be terminated to clip-in SAC-R or equivalent knife-edge disconnect-type terminals mounted on DIN rail. 10% or 40 minimum spare terminals shall be provided. All wires shall be terminated with a compression-type insulated spade or pin terminal. IS circuits shall use blue trunking in terminals. All wires shall be tagged using slip-on, heat-shrink type markers. Hash 6.3.4 earthing. Each panel section shall be supplied with two 6mm by 25mm tinned copper earth bus bars at the bottom of the panel. One bar shall be isolated from the panel frame and used for earthing the shields of all signal cables. The second bar shall be used for equipment grounding. Seller shall provide grounding drawings specific to the installation, showing all system cabinets and AC/DC signal wiring, and all grounding recommendations for tying the system into the plant grounding. Tashtahar 6.3.5 Power Supply and Distribution. Electrical equipment shall be suitable for 110-volt AC 50 Hz single-phase power supply from a UPS. Redundant feeders shall be supplied to each panel, each capable of taking the full load of the system. The system shall include isolation transformers to prevent electrical noise interference. Power distribution cabinets will provide 20% spare feeders of each rating, with an additional 10% spare space for future requirements. All power supply units shall be monitored for faults by hardwiring into the system as digital inputs. 6.4 Ventilation. Ventilation requirements shall be arranged to avoid the creation of local hotspots. Forced ventilation systems shall not be fitted unless agreed by the owner. If supplied, forced ventilation systems shall consist of twin paralleled systems, each rated at 100% duty, fed from a UPS via dedicated fuses and circuit breakers. 6.5 Identification. Each equipment item shall be identified by its unique project number via legend plate mounted on the front exterior face of the cabinet. Legend plates shall be manufactured from grade 316 stainless steel, deeply engraved and filled black. Legend characters shall be boldly engraved and 15 mm high. Tash 6.6 Painting. Cabinets shall be painted in accordance with the owner's painting specification, 99P00 JAM J00-003. Cabinets shall be painted inside and outside beige semi-gloss as per BS 4800 code 10C31. Internal equipment sheets, brackets, and cable trays shall be painted white gloss. Cabinet plinths shall be part painted black semi-gloss and finished on site following welding down. 6.7 Electrical Requirements. 6.7.1 General. Installation and wiring of all panel-mounted equipment shall be in accordance with applicable Indian standards, codes, and local statutory regulations. 6.7.2 System Cables. Intercabinet cables shall be of prefab type with plug-pin connectors at both ends for faster commissioning and lower wiring errors. Seller shall provide a schematic diagram showing cable types, plugs, terminals, and involved panels. 6.7.3 Serial link cables. The serial link cables shall be supplied by the seller. 6.7.4 Other cables. The seller shall advise of any other special cable requirements for the system. 6.7.5 Intrinsic Safety. All sensors solenoids shall be part of certified intrinsically safe circuits with shunt diode safety barriers. Barriers shall meet the requirements, EXIA IA T3 as a minimum. Each barrier shall be identified on the mounting rail by labeling with loop tag number, rail identity, and barrier position number. HAR 6.7.6 Lighting and Power Socket Outlets. All cabinets or suites of cabinets shall be provided with tungsten bulkhead light fittings and manual on-off switches. Each equipment cabinet or suite of cabinets shall be provided with a 110 volts 240 VAC power socket outlet, Wilco type number WM1102R1F. NASH 66707 Relays. Output interposing relays shall be miniature plug-in, inert gas-filled, hermetically sealed, with 4-pole changeover contacts, gold-plated contacts, LED indications, and coil 24-volt DC, 3 volts. 6.78 Earthing. Panel metalwork shall have electrical AC mains supply earth with 2 M10 brass studs per panel section. Instrument clean. Earth shall use an electrically insulated copper bus bar separated from panel metalwork by 25 millimeters. An intrinsically safe earth bar shall comply with AS 176 Part 4. 6.7.9 Electronic Modules. Electronic modules shall be identified as to type and function on the front panel with a unique serial number. 6.7.10 Printed Circuit Boards. Printed circuit boards of all electronic modules shall be coated with non-tracking varnish, with copper tracks at least 65 microns thick. 6.7 to 11 Lightning protection. Seller shall address the effects of lightning strike and provide recommendations for lightning strike protection. Tashahar 6.7.12 Serial link isolation. Serial link isolation relays shall be provided within the field marshalling cabinets, certified suitable for use in a Zone 1 Group 2A T3 hazardous atmosphere. 6.8 Expansion contingency. There shall be an expansion contingency of 25% allowed for FMC terminations and associated subassemblies as indicated in Appendix B. Section 7. System Software. 7.1 General. The software provided shall facilitate the execution of all specified functions and future extensions to the system. Software shall ensure continuous availability of each function. 7.2 Standard Software. Standard software is defined as previously installed and operated satisfactorily in similar control systems. Requires minimal tailoring with agreed parameters to suit specified requirements. Scalable for different site sizes. Standard documentation available. Correction updating facilities available to all users. Latest version supported by the seller. Configuration function blocks and ladder logic conform to these definitions. 7.3 Non-standard software. Non-standard software development shall be clearly noted. Descriptive information on non-standard software shall be submitted for a full understanding of the proposed algorithm, programming structure, testing method, and documentation. 7.4 Program structure. All compiled software functions shall be constructed from individual modules with clearly defined interfaces. Each module shall provide a specific component function and be designed to ensure changes in one module require no changes to any other module. Programs shall be well documented with reasons for each module, notes explaining calculations or logic, and references to logic diagrams. 7.5 Programming languages. Programming languages supported by the operating system software shall be specifically detailed. Application program languages shall be stated. Programming languages should include hooks to the real-time database through database subroutine calls. 7.6 Editors, libraries, and system utilities. The system shall include a full-screen editor, routine library, and system utilities for programming and system maintenance. 7.7 System management and monitoring. Each networked SCADA server, workstation, RTU, and SIS RTU shall act as an SNMP client. Each SCADA device shall be monitored by the network management system and respond via SCADA networks. 7.8 Database software interfaces. 7.81 Real-time database. High-performance memory-based design for concurrent real-time SCADA functions. All access based on structured query language, ANSI SQL 92 commands. SQL access possible from seller-supplied programs and custom user-written programs using C, C++, and Java. Graphical user interface for direct interactive user queries. Access restricted by user logon privileges. 7.8.2 Historical database. Real-time data saved into a disk-based historical database system using RAID disk array. Transfer of archived data to CD-ROMs via a CD-ROM burner. Database engine based on industry-standard products such as Oracle and Sybase. Proprietary database systems are not permitted. Analog data treated as discrete snapshot samples, averaged and compressed over time. Discrete status data treated as timestamps on state changes. Sampling averaging intervals for real-time data processing into historical data are user-definable and configurable. System provides 1-minute averages for 7 days, 10-minute averages for 31 days, hourly averages for 1 year, daily averages for 5 years, daily maximum and minimum values for 1 year. 7.9 Control and logic functions. Control and logic functions shall be based on a library of standard configurable functions sufficient to execute all functional control requirements. Library includes continuous control functions, manual auto stations, adaptive and feed-forward control, calculation functions, signal transfers, sequence controllers, function generators, logic functions, and data manager suite of software routines. 7.10 Diagnostic software. 7.10.1 Equipment failures. Diagnostic software provides online and offline test programs to monitor system health and resource utilization, detects system malfunctions, and takes corrective action before affecting control system functions. Provides messages for invalid software operations, system hardware faults, and automatic operator-instigated control system reconfigurations. Maintains summary fault logs for each control system device. Provides failover and restart facilities without affecting real-time operations. Offline diagnostics for detailed tracing of faults. CASH 7.10.2 System Utilization. Utilities monitor key resource utilization such as CPU and disk capacity. Configurable alarm set points trigger alarms when utilization exceeds limits. Utilization data stored on the historical database for future comparison and trending. 7.10.3 Network Utilization. Network traffic monitoring to identify problems such as bad cables, connections, or defective devices. Network traffic level not to exceed 15% of LAN capacity. 7.11 Software licensing and revision upgrades. All software provided without ongoing licensing fees. All revision upgrades released before the final certificate provided free of charge for 1 year. Owner, as license owner, may transfer licenses if the plant changes ownership. HASHAB 7.112 Restart. Automatic restart to restore normal operation after critical hardware or software failure or major system suspension. Minimum operator involvement required during restart conditions. No need for program or configuration parameters to be downloaded from MCC, SMCC, or LCC for restart. Conditions causing restart include manual boot from bulk device, critical hardware or software failure, resumption of AC power, system changes loading, and operator initiation. Section 8. Pipeline Applications. 8.1 Configuration. The Operating Standby Pipeline Application Software PAS platform configuration shall form part of the MCC and SMCC control centers. PAS packages shall reside in their dedicated server computers and link via high-speed Ethernet LAN using TCP/IP protocol. The model shall receive specific quantified data from the SCADA database in a continuous stream. The entire measurement system shall be scanned at a rate specified by the SCADA seller for optimum model performance, determined during the leak sensitivity study. Results of all calculations shall be transferred back to the SCADA system databases. 8.2 Integration with SCADA. 8.1 Operator Interface. Daily pipeline operator interactions with the application software shall be performed via the SCADA System Man-Machine Interface, MMI, and operator workstations. Reconfiguration of system parameters shall be performed by a system engineer via the SCADA MMI. Hash 8.2.2 System Logging. All operator actions and PAS system calls via the SCADA Operator Console shall be logged on the SCADA System Event Printer. The printer shall log all events arising from the PAS system. Types of reports supported. Post-mortem reports defining values and status of key variables in the preceding period. Daily report summary of system performance. Configuration report. Additional printer can be connected to handle PAS reports due to activity by the system engineer and redirecting all output from the PAS, logs, reports, event. 8.2.3 Results. Results from the PAS shall be placed in a buffer after each calculation cycle and after completion of offline calculations. All output from the PAS shall be treated by the SCADA system as normal process variables. 8.2.4 Data Display. SCADA seller shall create mimic displays as required by Reliance. PAS shall display all inputs and outputs using SCADA MMI displays developed during the detailed functional definition stage. Displays required for calculated flow, temperature, pressure, density, and head profiles for the complete pipeline. Combination displays for calculated parameters, line plot, combined with measured parameters, bar plots. Alarm displays segregated from other SCADA system alarms where possible. System summaries, reports, batch pig tracking displays, batch scheduling displays, help mimics, leak location displays. Results from the PAS shall be available through a standard applications programming interface to facilitate easy selection of data to be transferred to the SCADA system.